Hello, today we're going to learn how to use glue constraints in Houdini so that we can fix this broken thing. So we learned about how to fracture in the previous lessons, and today we're going to learn how to glue together fractured pieces. So how do we do this? So the way we do this is to basically put some glue in between. And in Houdini, this is done using constraints. So a constraint is basically a line that connects two pieces. So you remember we had piece number 0 and piece number 1. And then these are connected with a line that is a glue constraint. And that is what we are going to do in this lesson. So let's jump into Houdini. And this is where we left off last time. I only cleaned up a little bit by adding some null nodes to make it more clear what each thing is. So here I call this high-res, that is the high-res version, and I call this proxy, that is the proxy version. And let's also add some extra boxes around the simulation. So press Shift O around these three nodes. And let's call this simulation. Simulation. And let's do the same with the last nodes. So Shift O, and let's call this, let's just make this a little bit bigger. And let's call this instancing. So now we can see more clearly the structure of this simulation. So we have the fracture that we did in the fracture lesson. And we have the simulation that we did in the bullet lesson. And we have the instancing that we first did in the RBD lesson. So let's now look at the constraints. So again, we are going to create this line connecting piece 0 and piece 1 using a glue constraint. So in the same manner as with these nulls, high-res proxy, I'm going to add also a constraints null. So let's press tab and type null and call this constraints. And I'm going to connect this to the second input of our simulation DOP node. And we are going to start with our line here and turn this into a constraint. So let's look at the geometry spreadsheet to see what data we already have. So we have 2 points and we have nothing on the primitive level. So here we want first of all to mark what kind of constraint this is. So let's press tab and type attribute wrangle and connect this after the line. And I'm going to call this constraint name. Okay, so this is constraint. This is too small to see. Let me just make it bigger. I will just type it from the beginning. This is quicker. Constraint. Okay, constraint name. And let's select this and press P to go inside. And here we want this to be on the primitive level. So change the run over to primitives. And let's type S for string, at for attribute, or rather for an auto binding if you watched my VEX or VOP lessons, but you can think of this as attribute. Sorry. Okay, so this should be constraint name. constraint name, and this should equal anything we want, but we call this glue because this is what we are creating. Okay, so let's press P to hide this, and let's look in the attribute spreadsheet, and now we have constraint name. So let's fix the spelling. So constraint name, and next we want to know the distance between piece 0 and 1, so the length of this line, and we can use a measure node to do this. So let's press tab and type measure and connect this after the previous node, and select this and press P, and here we can change what we measure to perimeter. Okay, so now we have the perimeter, and we shall call this the rest length. And press P. So now we have the constraint name and the rest length. And next we need to specify what these points are linked to. So point 0 should be piece 0 and point 1 should be piece 1. So let's add this information. So I'm going to add another attribute wrangle. So press tab and type attribute wrangle and connect this after the measure node. And let's call this name. And select this and press P, and then run over points, because we are going to add this here in the points area. And let's type string at name equal, and here we will say sprintf, and the S is for string, print is for printing, and F for formatted. So this will print to a formatted string, and call this piece %d, and percent here means replace this with a decimal number, and the number will be at ptnum, and ptnum is a global variable available here, as you learned in the Vex lesson. Okay, so now we have name piece 0 and piece 1. So now we know what pieces are connected with this constraint. Okay, so this is all we need for this constraint. So the points and what piece each point is connecting, and also the constraint name and the rest length. So let's connect this now to our constraints null. And let's jump into the top simulation. So now we have to wire up this information so that the bullet solver will be able to use it. So we are going to add this here right after the object geometry. So let's add a SOP geometry similar to what we already did before. So press tab and type SOP geometry. And let's connect this after the object geometry. And this will be our, well, let's not add it yet. Let's just disconnect this. And here we can call this the constraint geometry, constraint geo, and this will be grabbed from, if you press P to edit, and under SOP path we can use the backtick op input path, and here type ... for the previous level in the hierarchy, and (1) for the second input. You start counting from 0. And now if you middle click this, you can see this is now connected to our constraints. So this will bring in, if you select this node and rewind. Okay, this is still not, we need to connect this to actually see this being brought in. So let's continue and bring this into this network. So press tab and type constraint, constraint network relationship, and connect this in the chain after our geometry. And let's rename this to constraint. Okay. And now if we look in the geometry spreadsheet, if we select the end here, then we have here under relationships something called constraints. And let's select this and let's use the same data name, so $OS to use the node name. So now this is called constraints. And you can see that this is affecting the object and it is affected by the object. So this is a two-way constraint. And this will need the constraint geometry. So let's connect this into the first input. And now if we look at what we have, then we have a geometry here that is our constraint. And finally, we have to add this to be a glue constraint. So press tab and type glue and select glue constraint relationship. And then connect this after here in the constraints. And I will just call this glue to keep it simple, and press P to edit, and let's change the data name to $OS. And now this appears here as glue. So then let's, okay, that is good. So what is happening here is that the name that we see here, glue, is going to be related to the geometry constraint name, glue. So these two have to be the same. And you can call this whatever you want as long as they match. So this should now work. So let's run this simulation and see what happens. So you can see it is held together. And if we disable these constraints and try again, you can see that it breaks. So the constraint is working. And let's also visualize this constraint. So let's add a constraint visualizer. First of all, I'm going to hide something. So let's just press tab and type something volatile. And this is called rendering parameters volatile. And I will call this hide. And then press P, and we set the display to 0 and the render to 0. So this will neither be displayed nor rendered. So if I connect this, for example, to our object geometry, then this is not displayed. So now we can see the other one down here, that is the constraint. And it would be nicer if this actually was aligned with this geometry. So let's go back up one step. And let's copy this transform, or rather press the right mouse button, actions, and create a reference copy. And connect this in the constraint chain. So now the constraint will be transformed to aligned with the geometry. So let's go back now into our simulation. And now if I hide the geometry, you can see the constraint geometry is here. But this is just the initial data. It is, if I run the simulation now and I pause this, and let's hide that and run this, and you can see this is not moving because this is just used to initialize the constraint data. So we don't want to see that one. So I'm going to connect this hide to the constraint geometry and hide that one. And instead, let's add a visualizer to our constraint network. So press tab and type constraint and visualizer and select Constraint Network Visualization. And let's rename this to Constraint Viz as usual. And connect this here onto the constraints. And now if we hide the geometry, then we can see the constraint visualizer here. And now if I run, you can see that the constraint is moving together with the simulation. So this is the actual constraint being simulated. And let's unhide the geometry, and we can remove the visualizer because now we know how it works. And let's go back up and let's select the out node that we use for rendering, and let's run this simulation. And you can see it's held together without any issues. So we created a glue constraint by using a line that is identified with each piece. And let's see again, and this will then, well, yeah, I don't need to show this again, so sorry for the little interruption there. So I hope this was helpful, and see you next time. Over and out.